Lemnescates. What gives lemniscates away? Of course, it's r squared. It's the only one with r squared. If we see r squared, you know it's immediately a lemniscate. So I don't care if it's plus or minus for sine or cosine. Also, the coefficient of theta with a lemniscate is always going to be 2. So look for the squares on your A and your R and look for 2. Well, the 2 is going to tell us, well, there's always 2 petals. They're not roses anymore, but you could think of it as there's going to be 2 entities flying out from our 0, 0 pole, and A will tell you how long each of those, I guess we could call them petals, is. It's A, not A. So when thinking about a lemniscate, think about a figure 8. This will tell you the petal length, and this will be the number of petals, and that's the way it's going to be. So a positive cosine one is going to look like this. Of course, if you don't want to believe me, you can make a theta and r chart. You could pick theta and get r, and you would have something that looks like this. You're going to solve for r, and that means you're going to have plus or minus. And you'll eventually get something that looks like this. It looks like a figure 8. Well, here is our theta equals pi over 2 axis, and here is our polar axis, and this is a distance of A away. So if I said r squared is equal to, we've been calling this 5, right? So to be 25, well then this would be our point 50 for r theta. And it's going to look like this. It looks like a figure 8. Look, we've got all 3 types of symmetry because we have symmetry across the polar axis, across the theta equals pi over 2 axis, and you can see these 2 points are going to be commensurate, and so are these. So first and third quadrant and second and fourth. So that would be for plus cosine of 2 theta. Sorry, r squared equals a squared cosine 2 theta. Well, as soon as I see r squared and this is 5 squared, whatever is here, I take the square root of 5 squared. Square root is 5. And I know, oh, this is a lemniscate because I see that r squared. If I'm asked to graph this, it's a sine. Oh, sine still loves to live in the quadrants. So, of course, this would be my point. If I was doing r theta, I would pick pi over 4 and get this point as well. This is for a positive sine. What kind of symmetry do we have? Well, we don't have symmetry across the theta equals pi over 2 axis. We certainly don't have symmetry across the polar axis. We only have symmetry across the pole because we see this first quadrant and third quadrant symmetry. What if I put a negative out there? Well, sine loves to live in the quadrants, and this is what happens. Again, we only have polar symmetry here. This is the one, it has sine, but it doesn't have this theta equals pi over 2 symmetry like we would anticipate. And then we could pick these points and get those and say, oh yeah, I knew it was there, and it in fact was there. Notice, we only have symmetry across the pole. If I was playing this theta r game, I would pick 3 pi over 4, and I would get 5 here. And that would help me remember, oh yeah, that's what this looks like. So just a quick review. R squared equals positive a squared sine 2 theta is going to look like a figure 8. Notice we have all 3 types of symmetry there. And this distance is going to be a comma 0 there. Negative cosine is going to be a figure 8 but pointed vertically. We have all 3 types of symmetry here, and now our point is a comma pi over 2 for r theta. Look, cosine, even with lemniscates, loves to be bisected. R squared equals positive a squared sine 2 theta is going to be in quadrants 1 and 3. Notice these 2 had all 3 types of symmetry. This has only symmetry across the pole. Even though it says sine and we anticipate at least theta equals pi over 2 symmetry, we don't get that. This point will be a comma pi over 4. So you could pick pi over 4 and find out that that's a there. And if it's a negative sine one, we're going to be at a distance. This is going to be at our point a comma 3 pi over 4. And you can see that we have symmetry across the pole. And again, that's the only symmetry we have. Sine loves to live in the quadrants, just like it did with the roses. They do with the lemniscates as well. Cosine loves to be bisected by either the polar axis or the theta equals pi over 2 axis.